So basically, we're creating a pending intent, then we come into our onCreate here, and we actually go get the NFC adapter. And we're just grabbing the default adapter. There can be more than one. This is, I don't have anything that has more than one on it, but there can be. And then we're creating this pending intent, and I show this pending intent for a reason. One of the things that you don't know how familiar you are with pending intents or launching things from intents, but you want to do something like this single top so that as you tap it, you're not creating multiple instances of the same application over and over again. But then basically in our intent filter, we have 3 different intent filters here based on the different types. So tag discovered, NDEF discovered, or tech discovered. But I just show those here. Really, the only one I'm using in my array is the tag discovered one, because I don't really care if it's NDEF or whatever at the moment. I just want to get a tag, if you read a tag. I'm actually going to come down in on resume here, which is where I'm actually going to get the intent, and I'm going to check the NFC adapter, and if it's not enabled, in this particular case, I put up a little dialog box that says, you know, you're not enabled, take me to my settings and enable it. Otherwise, if you don't do that, it bails out on you. But the net result of that is if your NFC is enabled, then we're going to do this enable foreground dispatch, and we pass it this pending intent and our filters for what kind of tags we want. And now what's going to happen is in the foreground, with our activity running, it will bypass the other dispatch system and it will override whatever it is. So the application that's in the foreground has the opportunity to override the dispatch system of the operating system by doing this foreground dispatch model. I'll show you later how you can do that from your manifest to be able to get intents to launch your application from the OS level. Here, basically on pause, we turn around and we disable the foreground dispatch because we're good, clean programmers. Okay, so here's where the interesting stuff happens. This is on new intent. So this is where the actual intent comes into our application once we've tapped it. And so here we're basically, I apologize for this doesn't format very well, but it's ugly code anyway. But we're basically checking to see if the action in the intent matches action tag discovered, NFC adapter tag discovered. And if it is, this is how we actually get the tag from the reader here. Tag is an NFC object, and we can use this get parsable extra and actually get the tag data from that. In my case, what I'm going to do then is take that tag that I got, and I'm going to grab the list of technologies that's associated with that tag, and I'm going to pass it to this method here that's going to check to see if it has the technologies that I want to support. I'll show you that code later, but so we're just checking to see if this is technology we want. Then I'm going to pass it to something else to check to see if the tag is writable or not. And then I'm actually going to pass it to, and then I'm actually going to write it. And when I write it, I'm going to pass to it what I want to write onto the tag. So, and I pass it the actual physical tag. Does that make sense so far, or can you see that? Okay, so if we come down to actually write tag, we're passing it in an NDEF message. So, and our NDEF message has NDEF records in it. We're passing it the tag. We're going to grab the size of the message that we're trying to write to the tag, and then we're going to try and grab the formatted tag, the NDEF format for it. And this is how you do it: just NDEF get and pass it the tag. If it is NDEF encoded and formatted, then this will come back true, and you can just go ahead and connect to the tag. You can do things like see if it's writable. If it is writable, you can check to see how much space it has, and if what you're trying to write to is going to fit. And then you can actually go ahead and write the message. So
what happens if you try to write too much?
It'll fail. Just an exception. It'll be in the try catch here.
So the driver will return back failure of some kind.
Yeah, it'll return an exception. It'll fail. So if it wasn't NDEF encoded,
If you try to write too much, it will change the content of the tag.
I'm sorry, it won't let you write to it. I mean, so different tags have different amount of space. So an ultralight C will only have, right. So the tags range from 41 bytes to 32K. In the typical passive tags, it's really between 4 bytes and 8K, but the most common tags that you see out there are going to be around, for marketing purposes and product purposes, they're going to be in like an NXP makes a tag called the NTAG 203, which is 168 bytes of data, and for a lot of apps, that's low cost. And
I may have missed the point where you check to see whether or not there's any mistakes.
yeah, that was actually this part right here where, right here, max size. So if it wasn't formatted, then I can go ahead and format it. I can, if it, as long as it is formatable, I can format it and then connect to it and then write it. So the two differences are, is it formatted, formatted or not. I apologize, I'm getting my mouse around all over the place.
Click down there.
Okay. So here's the part where I actually decide what I'm going to write to the tag.
So does Android not have, like, this seems like a lot of code to write tags, these tags, and stuff.
Well, you don't have to do all the checking if you don't want to.
Is this not, is this not canned in Android? I was kind of surprised.
No, this is actually, if you did it before they had this, it's a lot more code than this. This is really easy compared to what it was.
But this is a library you wrote.
No. These things like check the size and all of that, that's all Android.
Okay.
Now, I'm just calling, I mean, this is an app here, but I'm calling the Android application record that you can write to a tag. It doesn't matter where you write it, because Android in this particular case will search all the messages and all the records in your NDEF encoded tag to see if there is an AAR in there. And you encode an AAR with your package name, or whatever package name you want. And what happens if you do that is that Android will forget everything else and say, I'm going to deliver this to that application. And if that application doesn't exist, I'm going to take them to the market to get it. But it's basically circumvents all the normal dispatch and says, hey, I want to do this. So I show it here in two different ways. This is turned off. If you look down the code below here, you'll see what I do if you made that true. But I'm just going to take a URL here, smartware.com/NFC HTML, and I'm going to get its bytes, and I'm going to create its payload, and I pass in right here the first character of the payload defines the prefix. And if you look at that NFC record Java file that's in here, you'll see the whole list of all the different prefixes and all the, see all the different HTTPS versus all the different URIs, basically, in reference to it or encoded in that. So you can look at that to see what the different ones provide. So this particular one will put HTTP//www in front of that payload. I'm copying them all together, and then here's where I actually make the record. So it's a new NDEF record. I'm passing it. It's a well-known type. It's a type URI, and I'm passing it the payload. So that's, I'm not passing it. I'm creating a record that contains that information. And then I'm going to wrap that into a message. In the two scenarios here, where I turn on the Android application record, I'm going to create a message and I'm going to pass it that record, but I'm also going to pass it an AAR. In this case, I actually have it not to this application, but to a different application, the read, not the write. Otherwise, I'm just going to return the URI record. So this is what's going to actually get written to the tag.
Could you just use a URL